6.1a and b is going to have us simplify exponential expressions, either using the expansion method or just the properties and the rules. So if we look at number 5 here, negative 2 to the 9th power times negative 2 to the negative 4th power. If you use the property of exponents, they have the same base, so in this case you would just add the exponents. So if you add 9 and negative 4, you get 5, so this simplifies to negative 2 to the 5th power. If you had to simplify that, negative 2 to the 5th power is actually going to equal negative 32 as the final answer. Number 6, we have these three powers that all have the same base of an 8, and 8 to the 3rd times 8 to the negative 5th times 8 to the negative 7. Because of that, again, you can just add their exponents. So what you would do in this case is you would do 8, and you would take 3 plus the negative 5, and then plus the negative 7. If you add those together, you're going to have 3 plus negative 5 is negative 2. Negative 2 plus negative 7 is negative 9. So you would have 8 to the negative 9th power. Now you can't have negative exponents, so you can make any number a fraction by putting it over 1. You're then going to take the power and bring it down below the fraction bar. That's going to give you 1 over 8 to the 9th power as your final answer. Number 7, you can start one of two ways. You can either simplify the 4 to the 5th divided by 2 squared, or you can distribute the 3 through. I'm going to take care of what's in the parentheses first. So when you have 4 to the 5th divided by 4 squared, what you can do is subtract the exponents. So 5 minus 2 is going to be 3. So this is 4 cubed, all to the 3rd power. Now what you would do here is you would multiply your exponents. So 3 times 3 is going to be 9. So the answer to this is 4 to the 9th power. Another way to think of the problem at this stage is this says 4 cubed 3 times. So if you were to expand this out, what it would look like is 4 cubed times 4 cubed times 4 cubed. And then if you were to further expand these out, this one says you have 3 4s, some more 3 4s, and more 3 4s. Altogether, you would have 9 different 4s, which would give you this answer. Moving on to number 8, we have 3 over 5, which can't be simplified further, all cubed. In this case, what we want to do is actually either you can repeat this base 3 times, or the trick is to distribute the exponent. If you were to repeat the base, it would be 3/5 times 3/5 times 3/5. What you're going to notice is this would become 3 cubed on the top, and this would be 5 cubed on the bottom. Well, if you do the trick of distributing the exponent, what you're going to see is this is 3 to the 1st power, and this is 5 to the 1st power. So when you distribute the exponent, it's 3 times 1 and a 3 times 1 here. So you're going to get 3 cubed over 3/5. And that's your final answer. Again, we could have just looked at it from the expansion method here and then taken the expansion method and condensed it down. Number 9 here can be handled a variety of ways also. One thing you could do first is you can get rid of the negative exponent here by bringing it down in the fraction, or you can distribute the 2. Let's go ahead and get rid of the negative exponent first. So what I'm going to do is put this over 1, and I'm going to bring the y to the 4th down. So we're going to have 8 y to the 4th. Don't forget this whole thing is squared, and then it's y to the 8th. Now this 8 has a power of 1 to it, so what I can do is take the 2, and I can distribute the 2 as a shortcut, or repeat this twice. If you repeat this twice, you're going to have 2 8s on the top. You're going to have 2 y to the 4s on the bottom. What will happen when you distribute, this will be 2, and that'll become a 2 times the 4. So what you're going to get is you're going to get 8 squared over y to the 8th power. And then you have this all times y to the 8th. Now if you look at this, you can just do y over 1 this way. So when you have it, what you can actually do is you're going to notice is you can cross out y to the 8th and y to the 8th. So those get crossed off. And then all you're left with is 8 squared on the top. 8 squared can be simplified to the answer of 64. For number 10, let's actually distribute this exponent first before we change this exponent to a positive, and I'll show you it will work. You do have to be careful. The 2 does have a little exponent on it too. So this 3 has to go towards the 2, towards the u, and towards the y. So what you're going to end up having is 2 times to the power of 1 times 3, and then u, and it's 4 times 3, and on the bottom it's y to the negative 3rd times 3. When you simplify that, what you're going to see is it's going to become 2 cubed times u to the 12th over y to the negative 9. Now we can't have negative exponents, so what I do is when I cross over the fraction bar, it becomes positive. And in doing so, we'll end up getting ourselves our final answer. I'm going to do 2 cubed is actually the number 8. So 8 u to the 12th and y to the positive 9th is our final answer. Number 11, I'm going to go ahead and actually take care of this 3. This 3 can go towards the x and towards the 4. Again, let's don't forget that the 4 has a little 1 there, so we'll kind of put that as its exponent. When you distribute, it's going to be 3 times 1 and then the 3 times the 2. So we're going to see it's 4 to the cubed, and it's going to be x, be careful, to the 6, 2 times 3. And then it's x to the 5th on the outside. In this case, we can combine these together by adding the exponents. At the same time, 4 cubed we can do. 4 times 4 is 16. 16 times 4 is 64. So this simplifies to 64 and x to the 11th power as a final answer. For number 12, let's go ahead and get rid of this negative exponent first. So x to the negative 2 I'm going to bring up. When I do that, what we're going to end up getting is it's going to become x to the 6th, y cubed, and then x to the positive 2, and then it's y to the 4th. Now if we look at it this way, our x's can be combined. There's 6 here, there's 2 here. These become x to the 8th. So we'll do x to the 8th. Now the y's here, there's 3 y's on the top and 4 on the bottom. What would happen is you can cross off all 3, and if you cross off 3 here, you'll be left with 1. So we're going to have, notice, the y is going to be on the bottom. Our final answer is done because we have a single x term and a single y term, and we are done. Now another way you could have handled the y's, by the way, is this. If you use the property of when they're being divided, you can subtract the exponents. So remember, 3 minus 4 would have gotten you on the top y of negative 1. You can't have negative exponents, so what you would do is bring it down. When you bring this down, it brings the y to the first down on the bottom, which is what we got when we did it our method. 6.2b and c, one is to identify if the equation is a polynomial, and if it is, identify the degree and leading coefficient. So for these two problems, it says tell whether the function is a polynomial. If it is, write it in standard format, and then state its degree, type, and leading coefficient. Of these two equations here, one is a polynomial and one is not. Polynomials mean the variables have integer exponents that are only positive values. So here this is a positive exponent, so that's good. This is a positive integer, and that's fine. Minus 4 is just fine because really what's there is an x to the 0 power, and there's nothing wrong with that. That still makes it a polynomial. However, this one right here, if we were to write it out, this is really x to the 1/2 power. Square roots are not positive whole number exponents. So this term right here breaks it, and this is not a polynomial. This second one here, if we look at it, x cubed is great. It's a positive integer. X squared, it's a positive integer. Again, you can minus a constant value from it because there really is a variable there. You just don't see it. It's x to the 0 power. And x to the 0 power is just 1, so we normally never write that. This itself is a polynomial, so yes. The degree is the highest exponent. In this case, the highest exponent we see is a 3, so it's third degree. A third degree has a unique name. It's called a cubic. The leading coefficient is found where you found the degree, so go to the term with the highest degree, and the coefficient in front of that term is the leading coefficient. So in this case, it's 1/2. Now, they want this to be in standard format, which means the highest exponent first. So it would be x cubed, x squared, and then the constant value. So if you were to write this, all you'd have to write is really nothing different. It's still going to look like 1/2 x cubed minus 2x squared, and then you would just put minus 1.1. Do not write the x to the 0 power, because again, we typically never write those. 6.2e wants us to graph a polynomial function, and they want us to use the calculator. Let's actually graph this and show a table of values first, and then we'll put it in the calculator to confirm if we're right. So here it says graph using the domain. That just means the x values of these. So when you do this, what you're going to want to do is make a table of values. and they are already telling us what they want the x values to be. So they want -3, -2, -1, 0, 1, 2, and 3. If we can find their corresponding y values, we can plot these ordered pairs and see what the shape of the graph would look like. So let's just walk through a few of these. If we put in for -3, I'm going to put -3 for x and simplify. So to do that, what it would be, it would say -2 times -3 cubed plus 6 times -3 plus 4. When you simplify this, what you're going to get, -3 cubed is going to become -27. -27 times -2 becomes 54. This is going to be -18 and then plus 4. So I'm going to do, we'll just write -18 and then plus 4. When you simplify this value, you're going to get that the answer is 40. Let's walk through another one. How about when x is 0? So there'd be -2 times 0 cubed plus 6 times 0 plus 4. Well, 0 cubed is 0. 0 times -2 is 0. This is 0 and this is 4. So the answer here is 0, 4. Let's do another one. How about when x is 2? When x is 2, we're going to have -2 times 2 cubed plus 6 times 2 plus 4. 2 cubed is 8 times -2 is -16. 6 times 2 is 12, and then plus 4. Simplifying these values, the answer is 0. So when you go ahead and graph this, now let's go to the graphing calculator. Under the y equals button, type in this function. After you've typed this in, you can either go ahead and hit zoom standard, which is number 6, or the graph button. When you look at the window, you're going to see a feature of a graph that looks something like this. Plot some of the ordered pairs to get the unique shape. Here's what it'll look like. Your polynomial should be somewhat of this shape. Also, if you want to get the other values for your table, if you hit second graph or second table, you can actually see the various ordered pairs. You're going to notice that -2, its corresponding y is 8. At -1, it's 0. At 1, it's 8. And when you go to 3, the corresponding number is -32. So you can complete your table that way. 6.2a and 6.3a wants us to write polynomials in standard format, so that means the highest exponent first, and then add and subtract polynomial expressions. So number 18 wants us to add, 19 is subtract, and put the answer in standard form. Adding is pretty simple. All you need to do is combine your like terms. So when you look at this, you can see the like term is the same variable to the same power. So x to the fourths are like terms. We have x squareds are like terms. And then the constant values with no variable are like terms. When we put it in standard format, we'll put x to the fourths first, then x squared, and then the constant. So let's go ahead and add it. Here we have 4x to the fourths minus 3x to the fourth. That's going to leave us with 1x to the fourth. For the squareds, we have a -5x squared plus 2x squared, which is going to be -3x squared. And our constant is a +1 minus a 2, which leaves us with a -1. And that's our final answer. Subtraction is similar, but you have to be very careful. We're taking this first polynomial expression and subtracting this entire thing. Because we're subtracting the entire thing, we have to make sure we come on in and distribute the negative sign. So if you want to rewrite this problem, you can, and you might see it a little bit easier. It's 2x to the fourth minus 3x cubed plus x minus 4. But then it's minus x to the fourth, and it's a negative times a positive x squared, which gives you a -x squared. It's a negative times a -3x, which will become a positive 3x. And then it's a negative times a positive 1, which will become a -1. Now you can just combine the like terms together and simplify. So our x to the fourths are right here. We have 2x to the fourth minus 1x to the fourth, which leaves us with 1x to the fourth. The next would be the cubes. So we have a -3x cubed and no others. So I'll just -3x cubed. In terms of the squareds, we have a -x squared is the next one. Then we do have 1x and we have a 3x as like terms. That combined together is going to be a 4x. And then we do have some constant values. What we have left is a negative 4 and a minus 1. So negative 4 minus 1 is going to give us a minus 5. So this is in standard format and simplified, and that's our answer. 6.3b just wants us to add the distributive property to this and then add and subtract, and we will put the answers in standard format. So here we have to multiply through a 3 to this whole polynomial and then subtract out the 2 to this entire thing. So we'll multiply the negative 2 through. So let's go ahead and make sure we do our distribution on all of this and rewrite it. When we distribute it, we're going to have 3 times x cubed is 3x cubed. And then 3 times a negative x is negative 3x. 3 times negative 1 is negative 3. Then we're going to have a negative 2 times a negative 2x to the fourth. That'll become a positive 4x squared. Negative 2 times a positive x is going to be a negative 2x. And a negative 2 times a negative 3 is plus 6. As we put this in standard format, we have an x cubed, so that'll be first, so 3x cubed. X squared is next, plus 4x squared. We have 2 x's, so we have a negative 3x minus a 2x is negative 5x. And lastly, a minus 3 plus 6 would be a plus 3. That in standard format is the final answer. The next one, we're going to end this one, we have to distribute through a 2, and from this one a positive x. So what we're going to have to show here is let's bring a 2 through all of that and a plus x to all of this. When we simplify it, we're going to get 2 times x cubed is 2x cubed. 2 times 3x squared is plus 6x squared. And 2 times a negative x is negative 2x. Now this one here, an x times a negative 3x squared is going to give us a negative 3x cubed. A positive x times a negative 5x is going to be a negative 5x squared. And a positive x times a positive 9 is going to be plus 9x. Now to put this again in standard format, we have two different cube values. So 2x cubed minus 3x cubed is going to give us a negative 1x cubed. The next would be squareds. We have a 6x squared minus a 5x squared, so plus 1x squared. And then lastly, we have a minus 2x and a plus 9x, which adds to 7x. We've accounted for all the terms, and it's in standard format, so this is our final answer. 6.4a wants us to multiply polynomial expressions. So here we have one binomial times another binomial. In this case, we're just going to distribute the 4x to both and the negative 3 to both and rewrite it. So here 4x times 4x is going to be 16x squared. A positive 4x times a positive 3 is going to be plus 12x. A negative 3 times a positive 4x is a negative 12 and an x. And a negative 3 times a positive 3 is going to be negative 9. Adding our like terms right here, 12x minus 12x is 0. What we're left then, when standard format, is 16x squared minus 9 is our final answer. Now number 23, we have to multiply a binomial by a trinomial. What we need to do is just make sure that this x squared touches all three of those, and then we need to make sure we come back and that the 2 touches all three of those. So we have 6 sets of multiplication. So let's get started, and let's just do x squared times x squared. That's going to be x to the fourth. Then x squared times 3x is going to be 3x cubed, and it's positive. And x squared times a negative 5 is going to be negative 5x squared. The next one is a positive 2 times an x squared is plus 2x squared. A positive 2 times a positive 3x gives us a 6 and an x. And a positive 2 times a negative 5 is negative 10. Again, we're just going to put it in standard format and add our like terms. So we have an x to the fourth right here. That's first. Here's the x to the cube, so it's 3x cubed, and there are no others to add. We do have a negative 5x squared plus a 2x squared, which combines to be a negative 3x squared. Here's the 6x, and it's plus 6x minus 10. We've accounted for all the terms, and it's in standard format, and that's our final answer. Now the last one here is 5x minus 1 all squared. Now be careful, do not distribute the 2 here. You can't use the trick here. You must repeat the base twice, just like what the rule says. So if you repeat that base twice, what you have is 5x minus 1 times 5x minus 1. And it's really like a problem like we just did up here. So all you need to do is distribute the 5x here and the negative 1 here and simplify. When you do that, 5x times 5x is going to be 25x squared. 5x times a negative 1 is a negative 5x. A negative 1 times a positive 5x is a negative 5x. And a negative 1 times a negative 1 becomes a positive 1. We have two like terms here. Negative 5x minus 5x will become negative 10x. So we have 25x squared minus 10x plus 1. All like terms are combined and it's in standard format, so we are done. 6.4c, we're going to long divide polynomial expressions. So here we have a second degree polynomial and they want us to divide out a first degree polynomial. So I'm going to put this under the division sign and we call that the dividend. So when we set it up, we're going to have x squared minus 5x plus 6. The divisor in this case is x minus 3. Now the best way to approach this is just to look at the x here and the x squared. So the question is, what do you have to multiply x by to make it be an x squared? If you can't see it, what you can do is just write this down. X times something is going to be x squared. What's the missing value is another x. So that's what goes up here is another x. So again, what do you multiply x by to get x squared? You do an x, that's what goes here. Now what you need to do is multiply this through. X times x is x squared, so I'm going to line it up right here. X times a negative 3 is negative 3x, so line it up with its like terms. So negative 3x. Now you have to make sure you come on in here and you need to subtract. So you need to subtract this term, which means you're going to say x squared minus x squared, that's just 0. And negative 5x minus a negative 3, be careful if you want to, what you can actually do is imagine that you're distributing this negative sign here, so this becomes positive. So that would really be a plus 3. So negative 5x plus 3 is going to give you a negative 2x. Now you finish up by bringing down the values we didn't use, which is the plus 6. So really what you can do is ignore that this 0 was here. That is one round of long division, and you just start over. So now you have to say, what do you have to do to an x to make it a negative 2x? Again, what do you multiply x by to get negative 2x? Negative 2. So now you have to come on in here, and what you need to do is you need to multiply the negative through 2 here through. So negative 2 times x is going to get you negative 2x. Negative 2 times a positive 3 is plus 6. Now you need to come on in and subtract. One way you can do this is just change the sign of these two terms. So if you have to subtract them, this becomes positive and that becomes negative. When you add down, negative 2x plus 2x is 0. And then you have plus 6 minus 6 is also 0, which means you have no remainder. So the answer to your long division is x minus 2. Let's look at one more. This is the dividend and that's the divisor. Now you have to be careful. This is in standard format, but you notice it goes from x cubed all the way to the constant. You don't see the x squared or the x term, unlike you did here. So you want to put placeholders. So when you set this one up, what you're going to want to put under the division sign is this, is x cubed. There is no x squared, so there's 0 x squareds and there's 0 x's. But we do end up with a minus 8 at the end. The placeholders should not have 1s in front of them, only 0s. Again, this is the divisor on the outside, so x minus 2. And then we're going to do just what we did before. What do we have to multiply x by to make it an x cubed? Again, if you don't see it, you have to take x times something to make it equal an x cubed. All you have to do is pull an x out of here, so it means we need an x squared. So on here you're going to say you need an x squared. Then you're going to want to come on in and take the x squared and multiply it through. When you do that, what you're going to get is x squared times x is x cubed. So line it up with your x cubes. X squared times a negative 2 is negative 2x squared. So line that up with your other x squared. You're going to notice we needed that placeholder there. Now you're going to come on in and you're going to subtract what we just did. So I'm going to change this to a negative and change that to a positive and add them together. X cubed minus x cubed goes away. We made that happen. 0x squared plus 2x squared is going to come up to be 2x squared. Now you finish off the first round by bringing down the other terms we didn't use yet. That's our first round of long division. Let's do the second round. What do we this time have to do to the x value here to make it a 2x squared? Well, this x needs a 2 and it needs another x. So I have to multiply x by a 2 and another x, so 2x. And it's a positive value, so I put plus. Then I'm going to come on in here and multiply this through. So therefore, what I'm going to see is I have to do 2x times x, it's 2x squared. And that's just going to go right here. A 2x times a negative 2 is negative 4x. So line that up with their x terms. We then are going to come on in, and again, don't forget subtract. So when we subtract that, it changes the signs. 2x squared minus 2x squared is 0. 0x plus 4x is going to actually give us 4x. And then we're going to bring down the minus 8. And we're going to do one more round of long division. So now we have to say, what do you have to multiply x by to this time make it a 4x? Clearly what we're missing here is the 4. And it's a positive 4, so say that it's plus. Now we're going to come on in here and we're going to do the multiplication one more time. So what we're going to end up writing is going to be 4 times x is a positive 4x. And then we do 4 times negative 2 is a negative 8. Now we need to come on in and make sure that we subtract these out. So when you subtract it, this becomes minus, that becomes positive. When you add down, 4x minus 4x is 0. Negative 8 plus 8 is 0. So it ends up that there is no remainder. And the final answer to this problem is right up here. It's x squared plus 2x plus 4. 6.6a and b is going to have us factor polynomials in quadratic form or solve them in quadratic form. You're going to notice these 4 problems, none of them say equal to 0. That means we are not going to solve. All we have to do is factor. If this had said equal to 0, then we would have to factor and solve. So we're just doing the first step on all of these. So let's get started. Now for number 41, what we want to do is break this into 2 binomials. So if we look at this, the 2 binomials we can break it into. How do we do it? Well, the 16x to the 4th has to be broken up and go here. And then the negative 1 has to be broken up and go here. And when we do the math on it, what's going to happen, this term and this term, when we multiply and add, you're going to notice there's nothing in the middle, will become 0. So what we need to do is equally break up 16x to the 4th into 2 pieces. The only way to equally break up x to the 4th into 2 equal pieces is to give each one of those an x squared. So this guy gets 1x squared, and this gets the other x squared. Now you have to think of factors of 16. It's either 16 and 1, 8 and 2, or 4 and 4. Now, if the numbers in your problem all become nice perfect square roots, the odds are it's the perfect square root number. So the square root of 16 is 4, the square root of 1 is 1. These are nice perfect squares. So the odds are the right combination for 16 is 4 times 4. So let's use the 4 times 4. You're going to notice, by the way, 4x squared times 4x squared is 16x to the fourth, so that's right. Now, to get negative 1, there really is only one way. It's going to be a positive 1 times a negative 1. So I'm going to come on here and do plus 1 minus 1. Now I can check my work, and here's what you do. This one right here is a positive 4x squared. This here is a negative 4x squared. If you add these two terms up, there's going to equal 0, which means there's nothing in the middle, which is correct. Now, this is the first step of factorization. Unfortunately, one more of these can be factored. This second term here can be factored into another binomial. So let's go ahead and first keep the 4x squared plus 1 as being done. And then I'm going to break this guy up into two more binomials. So what we need to do again is 4x squared has to go here and here. And then the negative 1 is going to go here and here. Notice again, 4 and 1 can have perfect square roots of 2 times 2 and 1 times 1. So the odds are to equally break up 4x squared. We already know for 1 it's an x and an x. It's the only way to equally divide an x squared. But it's either 4 and 1 or 2 and 2. It's probably 2 and 2. How do you get multiples of negative 1? Plus 1 times negative 1. So it's going to be a plus 1 times negative 1. Now the way to check is when you multiply this and you add them up, you're going to notice there's nothing in the middle, so it has to equal 0. Well, this is 2x, this is negative 2x. These two values add to 0, which is their Knoll's middle term. Now, this is factored completely because it's down to a single x to the first power. This one's done also. This one is not factorable. So the final answer here is exactly what we have. Now, if you were struggling with 41, I encourage you to try 42 by yourself now. It actually works very similar to this problem. We're going to have to factor this in two separate times. Notice the numbers 81 and 16 are perfect square roots of something. The square root of 81 is 9, the square root of 16 is 4. So when you factor it, the odds are you're not going to use 81 and 1, you're probably going to use 9 and 9. For 16, there's lots of them. 16 and 1, 8 and 2, 4 and 4. Odds are it's 4 and 4. So let's do the first set of factorization on it. To break up an x to the fourth, the only way to do it is an x squared and x squared. Again, because that's first here, it has to be first in these two binomials. Remember, we said 81 is probably 9 and 9. Now what we have to do is take the negative 16, the factors of that are last. It's last in the problem, it's last in the two binomials. Again, odds are it's a positive 4 and a negative 4. If I do a positive 4 here and a negative 4 here, and if you check it, this is a positive 36x squared, a negative 36x squared. That would add to 0, and you see that there's nothing in the middle. This first binomial cannot be factored further. Even if you tried it, it won't work. But this second one can. So let's rewrite the first and keep it as 9x squared plus 4. I'm going to break the second one up. And I want you to notice another pattern. We have 9 and 4. The square root of 9 is 3. The square root of 4 is 2. So when you're trying to find the right combination, is it 9 and 1 or 3 and 3? Is it 4 and 1 or 2 and 2? It's probably the 3 times 3 and the 2 times 2. It may not be, but it probably is. So let's take the first term and put it into the first spot here. X squared, again, is equally broken up into x and x. I need two numbers that multiply to 9. It's probably 3 and 3. Now I need two numbers that multiply to negative 4. It's probably plus 2 minus 2. If you do plus 2 and minus 2 and you check it, here's what you get. 6x minus 6x. These two add to 0. Notice there's nothing in the middle. These two binomials are completely factored because they're to the first power. You can't go any further. This is squared, so you should try to factor it, but this one will not work because you'll always get something in the middle as a term, and we can't have that. So we do have the final answer. It's this right here. Now 43 and 44 are different from that of the first two. You're going to notice here that the square root of 2 is not a nice perfect square root, neither is 30, so it doesn't work that way. What you're going to want to do for these two problems is to look at them and see if there's anything you can pull out of all three of the terms. So are there a unique number of x's that they all have in common, or a certain number? Well, if you look at this first term, there's actually 5 different x's. So if I were to write them out, you'd see 5 of them. This second one has 3, and the last one has 1. So you have to be able to pull the same amount out of everything. So the only thing you can pull out of them is 1 x altogether. So you're going to actually write that you're pulling out an x. Now when you pull out the x, make note, you're going to take 1 out, you're going to take 1 out, and take 1 out. So what's actually left? In here, there's only going to be 2 x to the 4th left. This next one is going to be negative 16 and x squared. And the last one, it's just going to be plus 30 because we're pulling the x out. The next thing you want to see is there a common factor or a number you can pull out of all 3 numbers. You can actually take a factor of 2 out. So let's write that we're going to pull out the factor of 2. And I'm going to put 2x. So 2 divided by 2 is 1, so that just becomes 1x to the 4th. Negative 16 divided by 2 is going to be negative 8, and it's x squared. And positive 30 divided by 2 is going to be a plus 15. Now, don't just have the 2 and the x disappear, you have to keep them on the outside, because you need to be able to say if you were to multiply these back through, you're going to get the original problem. So don't get rid of that 2x. Now when you look at this trinomial that's left over, we can factor that further. The 2x is fine because it's a single x to the 1st power. So what you're going to write here is just keep the 2x, and then let's further break down this trinomial. Now the key here is that the x to the 4th is the first term, so it's broken into the first here. There's only one way to equally break up 4 x's, and that's going to be an x squared and an x squared. Then the next thing is factors of positive 15 are last. They go here and here. What you're trying to do is when you multiply this term and this term, it's going to add back to negative 8x squared. So what are factors that multiply to positive 15 but add to negative 8? That would be minus 5 and minus 3. And you can check it. This is negative 5x squared. This is negative 3x squared. These two values would add to negative 8x squared, so we are correct. Now you need to stop and think if you can factor these further. The only way to factor a binomial that has a square to it is if this is a perfect square root. 5 and 3 are not perfect square roots, so we can go ahead and circle this as our final answer. Now if you were struggling on 43 but walked through this, you may want to try 44 on your own. It's going to work the same way. Now this is 5x to the 6th minus 30x to the 4th plus 25x squared. The square root of 5 doesn't work well. 25 does, but not a 5, so you can't do what we did up here. You want to look and see how many x's you can yank out of everything altogether. Again, at the most, this first term has 6 of them. So I'll write that. This next one has 4, and the last one has 2. So what you can do is you can take 2 x's out of each one. So let's write that we're going to pull out an x squared and take out the 2 x's. What's left over then is going to be 5x to the 4th minus 30x squared plus 25. Now before you go further, see if you can pull out a multiple out of all 3 of these values. You can easily pull out a factor of 5. So let's pull out a 5 and put 5x squared. So 5 divided by 5 is just 1. Negative 30 divided by 5 is a 6. And 25 divided by 5 is 5. So 5x squared is good. It's a single monomial, second degree. This trinomial can be broken into 2. So let's keep the 5x squared, and let's break the trinomial into 2 binomials. Again, x to the 4th gets equally broken up to here and here. Only thing we can do is x squared and x squared. Factors of 5 are going to go here and here, such that when we multiply these 2 terms together, it adds to negative 6x squared. So what 2 multiples multiply to a positive 5, yet add to a negative 6? That'd be a negative 5 and a negative 1. So let's do negative 5 and minus 1. Now this problem here, unlike the last, is not complete yet. This term is good, 5x squared. X squared minus 5, 5 is not a square root. That comes out nicely, so this is done. However, this last one can be factored further. The square root of 1 is 1, so you need to try this one. So what we're going to do is we're going to keep the 5x squared and the x squared minus 5. But the x squared minus 1 can be factored further. I need to break up x squared equally, so that's just going to be x and x. I need to find multiples of -1 and put them here, such that when I multiply, you're going to notice there's nothing in the middle. It adds to 0. So multiples of -1 that add to 0 would be +1, -1. So here it's going to be +1 and -1. This now is our final answer, and it cannot be factored any further. And that's it. 7.6 A, B, and C. One is to identify zeros using a calculator, identify the number of turning points, and identify the local max and mins using a calculator. So we have two problems here. These both are polynomials. This is a polynomial of degree 3. This is a polynomial of degree 4, and they're both in standard format. So let's start with number 49, and let's put this in the graphing calculator and transfer the picture onto the graph paper. When you do, you're going to get a graph that looks something like this. Now they want to know what is the total number of turns on this graph. Remember, the number of turns is its degree minus 1. So it's third degree, so degree minus 1 would be 3 minus 1, or the number of turns is 2. And you can see that. Imagine you're driving on a road. If you're traveling, you're going straight, you turn your steering wheel once. You go straight again, you turn your steering wheel twice. So there's 2 turns on here. Now they want to know the local max and the local mins. So the local maximum here looks like it's right here at this point, and we can find that. The local minimum is going to be the lowest point right here. So remember, to find the maximum, you're going to go to your calculator and you're going to go to second calc, and you're going to choose the maximum. When you do max, you're going to do left bound and then right bound. You're going to have it guess, and it's going to land at the maximum actually happens on the ordered pair. Jot this down. It's -0.67 and 1.48. And that's this maximum here. Now to find this local minimum again, you're going to use your calculator. You're going to do second calc. You're going to say find the min. You're going to travel to the minimum, do left bound, hit enter, do right bound, hit enter, and it's going to guess. It's going to land at the local min, which is going to be at 2 and at -8. That's this point right here. The last thing they want you to find here are the zeros of the function. This has 3 zeros. They sit here, here, and here. To find the zeros, again, you're going to have to go to your calculator. You're going to have to do second calculate, and you're going to have to say the 0. You're going to have to find the first 0 and go left bound and right bound. When you do that, this first 0 right here actually happens at the ordered pair of -1.23 and 0. Now you're going to have to go and find this 0 and this 0 too. When you do that, you're going to find that they are at the ordered pairs of 0, 0, which is there, and 3.23 and 0, which is right here. Let's go ahead and graph number 51. So go to y equals and type this into the graphing, and then either hit zoom standard or just graph. When you do that, here's what your sketch will look like. It'll be something like this graph. Now let's answer the first question, the number of turning points. You can always get the right answer by finding the degree of the function and minusing 1. So the number of turning points is 3. Now you won't always see the 3 turning points in the graph, but you do in this one. Again, as we travel along it like we were driving in a car, this would be our first turn right here. We go a very short distance and do a second turn. Come on up and do our third turn. So we do see all 3 turns in this one. Now the local max and local mins. The local min on here is going to be right here at this point in the red. Our local max, we have 2 of them. There's one here and there's one here. So we're going to use the same calculator features that we did. Second calculate max, second calculate min to find those. When you do, here's what you're going to get for your values. Now this minimum here in the red comes in at about 0, -5. You have to be incredibly careful though. When you go to your graphing calculator, you're going to see the x value is probably going to kick back with this number right here or something close to it. This number here is scientific notation for it's times 10 to the negative 6th power. So what they really meant was something like this. 10 to the negative 6. You need to realize the decimal would have been moved 6 places to the left. This is very close to the number 0. So if you typed this number, you would be wrong and I wouldn't give you credit. You have to recognize its scientific notation for the number 0. Now let's continue on for the local maxes. Those are going to be at the two values of negative 0.58 and negative 4.47, which is right here. This one right here is about 1.7 and 4.6. Now the last thing we have to find are the zeros of the function. This one has two zeros right here and right here. So again, let's use the calculator and do second calculate 0. When you do that, you're going to find that the first 0 actually happens at the value of 1, 0. So that's where this one is. Let's find this one using the calculator. You'll find that the second one here happens at about 2.18 and 0. And that's how you do these problems.